All right, guys. So we're gonna do what's up the practice exam. So let's go through this. So let's get ready to do it. So number one, find the simplified expression for the perimeter of the shape. So that's really going to be this side, you know, times two, right? Because it'll be the top as well, plus this side, and then on that side again. So you could just write it all out, or you could write it as two times that term and two times that term, right? But maybe just write it all out might be the easiest way to do that. So let's do that. So it'd be 7 root 5 minus 2 root 6, right? Just this one. And then maybe again, right, to account for the top. So plus 7 root 5 minus 2 root 6. And then now these ones. So 4 plus 4 root 5 minus 8 plus 4 root 5 minus 8. Okay, now just collecting like terms, right? So the 5s, right? Root 5s, root 5s, root 5s, root 5s. So it's really just 7 plus 4 plus 4, right? And then collecting all your root 6s together, and then just your numbers on the end, we end up getting an answer of B, right? So try that out. I'm gonna go through these pretty quick just so we can get through all of them and you guys aren't doing these forever. All right, so number two, it says express the fifth root of this stuff in simplified form. So the fifth root thing might be a little bit confusing, I guess, but let's say that you don't know how to like what your perfect root or powers of 5 are. Well, we can figure them out pretty quick, right? Let's just in your calculator write down, you know how we have our perfect squares. Let's write down our perfect powers of 5. So if you go, well, okay, well, 1 to the power of 5, that doesn't really count, right? Because, yeah, 1 to the power of 5 is still just 1. 2 to the power of 5 is 32. And 3 to the power of 5 is 243, right? So we're looking for those numbers, right? Either this one, or this one. That goes into 64, right? So let's split up that 64. Let's split up that 64 as, well, this one, right? 32. Because I know what the fifth root of 32 is. It's 2, right? So I'm going to split up that 64 as 32 times 2, okay? Now, so that's going to be good. I'm going to be able to take that 32 out. But now this n to the 10. So we might be thinking about splitting that one up. But, just for a second here, let's figure out do we know what the fifth root of n to the 10 is? That should be a 5, sorry, my pen's kind of off. Well, if you think about it, right, so n to the 10. I need 1, 2, 3, 4, 5 things that would all multiply to give me n to the 10. Well, what about 2, right? N to the 2 times 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 n to the 2. So those things, those 5 n to the 2's all multiply up to n to the 10. So the fifth root of n to the 10 is n to the 2, right? N squared, right? So I don't even need to split n to the 10 up into anything, right? I'm just going to call it n to the 10 for now because I know what the fifth root of n to the 10 is. So now what about m to the 15? Well, maybe you're starting to see the pattern here, right? That like m to the something, right? In this case, it'll be 3, right? M to the 3 to the power of 5 would be m to the 15, right? So the so the fifth root of m to the 15 would be m to the 3. Hopefully that one made sense. Maybe if you didn't like that one, then maybe do it the way we did down here, right? You could say m to the 15 could be split up, you know, in 5 different things. M to the 3, m to the 3, m to the 3, m to the 3, and m to the 3, right? So 5 m to the 3's would give you m to the 15. Yeah? So hopefully that made sense. So I'm going to leave this as m to the 15. And if you do that, we end up getting, so the 32 gets to come out as a 2, right? N to the 10 gets to come out as a n to the 2, and m to the 15 gets to come out as m to the 3. So if we do all that, we end up with, where is it? Where's my, oh, it's right there. Okay. End up with this one. Right? And we still end up with a 2 trapped in there. So that was D. All right, 3. So simplify this one. Okay. All right, so I'm just going to write it out again. So we got 3 root 175 plus 6 root 63. All right, so I'm looking for my perfect squares, right? Okay, so I'm going to rewrite 75 as 3 times 25 times 7 plus 6, and then I'm going to rewrite the 63 as 9 times 7. All right, so 25 gets to come out as a 5. There's already a 3 out there, so 3 times the 5 I'm bringing out is going to be 15 root 7 plus, okay, and then this 9 gets to come out as a 3. So 6 times the 3 that's already out there, so this will be 18 root 7. And then last thing here, we've got like terms, right? Root 7, root 7. I'm just going to add up 15 and 18, so we get B. Oh, that's not right. All right, number 4. Okay, so similar type of thing, right? So I'm going to, so it'll be 6. I'm going to rewrite this 80 as 16 times 5. Right? I could have done 4 as well, but if I did 4, I would have had to have done it again, right? I would have had to, like, you know, taking stuff out and then taking stuff out again. So I usually want to go for the bigger, actually I always want to go for the bigger square root if you can, right? So 16, then minus 2 roots, and then 20 I'm going to split up as 4 and 5. Okay, so the 16 gets to come out as a 4. There's already a 6 out there, so 6 times the 4 I'm bringing out, this will be 24 root 5 minus, I'm going to bring this 4 out as a 2. So 2 times 2, that's already out there, would be 4 root 5. Okay, and then lastly, I've got like terms again, 24 minus 4. So this one's going to be D. All right, 5. So we're multiplying a monomial times a binomial. We need to distribute. And when I distribute, I mean multiply, right? All right, so we're going to have negative 7 times negative 6 is going to be 42. And then 6 times 5 is going to be 30, right? Root 30, right? The square root part of it. And then moving on to the next line here, we've got negative 7 times negative 2 is positive 14. And then root 6 times root 6, I could call that root 36, but then root 36 is just 6, right? The other way of thinking about that is if I've got root 6 times root 6, or root 6 squared, it's just what's underneath, right? The square root and the square cancel, so that would just be 6. So just a big old 6, right? Okay. All right, and I'm noticing there's a mistake here. The answer on the key says it was C. This isn't going to be C. Shoot. So this will be 42 root 30 and then plus 20. Okay. All right, sorry about that, guys. I will compensate your guys' mark on the test. So, all right. I'll tell you guys in class what we did there. If you guys are watching this in a later year than this happened, I think I've probably changed it by now, so this was the answer. Okay. That should be good. Okay, moving on. All right, number 6. Find the simplified expression for the area of this shape. All right, so area is one length times the other, right? Length times width. All right, so that's going to be 3 root 7 plus 4 root 2 multiplied by the other one. So 3 root 7 minus 4 root 2. Oh, well, this actually ends up being a conjugate pair, right? Conjugate pair meaning that there is a addition sign there, subtraction sign there. Other than that, they're the same thing, right? So that's a conjugate pair. All right, so let's... I'll do the whole thing just to show you why it's going to work out, but what's going to happen here is our middle terms are going to cancel. But I'll do the whole thing to show you how that'll work. All right, so first one, we've got 3 root 7 times 3 root 7. 3 times 3 is 9. Okay, and then root 7 times root 7, that's just 7, right? We just talked about why that is. Okay, so that's our first term. So, okay, and then moving on to the next one here, right, that arrow, we've got 3 root 7 times negative 4 root 2. So 3 times negative 4 is negative 12. Root 7 times root 2 is root 14. Okay, and then we've got really the same thing happening in the next one, right? But it's going to be positive, so it'd be plus 4, or sorry, plus 4, plus 12, right? 4 times 3, and then root 14 again. Okay, and then the last one, I got 4 root 2 times negative 4 root 2, so that's going to be negative 16, and then root 2 times root 2 is just 2. All right, so here's what happened here, right? This is the whole point of a conjugate pair. Those guys just cancel, right? Negative 12 root 14 plus 12 root 14, they're gone. So yeah, they're out of the picture now. So now we've just got 9 times 7, so we've got 63 minus 32. And if we actually do that, we end up with 31. Okay. All right. And then 7. This is the one I said was a bonus because this ended up being a little bit tougher. So good job if you guys got that, if you figured this one out. So let's go 2 root 21 minus 3 root 7 over 7, root 7, sorry. Okay. And to tell you the truth, what we're gonna do here is I'm gonna rationalize this thing before we even get going, because what we're gonna have to do here is I'm gonna have to add fractions, and I got 7 on the bottom, and I don't like 7 on the bottom, or sorry, root 7 on the bottom. So I'm just going to ignore this guy for the time being, right? I'll add it at the end, but for now I want to just get rid of this root 7 or square root of 7, or the square root part of it. So I'm going to go root 7 on the top and on the bottom, right? That's how we get rid of that. That's how we rationalize that denominator, because we've really just multiplied by 1, right? Root 7 over root 7 is just 1, but we have to make sure we put brackets there, right? Because this root 7 is multiplied by everything on the top. All right, so let's do that. All right, so if I distribute that to both of them, we're going to get 2 root 147, right? 21 times 7. And then minus 3. And then root 7 times root 7, that is just 7. Okay? And then on the bottom, root 7 times root 7, that's also just 7, right? Okay, so we might want to clean this up a little bit. All right, so I'm going to write this as 2, and instead of 147, I'm going to rewrite this as 49 times 3. I don't really have to do this part of it right now, but I just want smaller numbers, or I'd like smaller numbers. So this 49 gets to come out as a 7. Okay, so 2 times the 7 that I'm bringing out. There. And I should write all this down. Okay, so minus 21, just doing this part, over 7. Okay, so now this 49 I was talking about, that comes out as a 7. So I've got 2 times that, so 14 root 3 minus 21 over 7. All right, so this is going to be a little bit easier to deal with. Now let's bring in the other part of this equation, right? So let's simplify this part of it now too. So we had 4 root 3 minus 8 over the square root of 4. Well, I could rationalize this. I could multiply both sides, like root 4, but I don't need to. I know what the square root of 4 is. So I'm going to rewrite this as just 4 root 3 minus 8 divided by 2, right? I don't need to keep that as root 4. That's just 2. All right, now we've got, is it minus or plus? Plus, okay. So now we're going to go this one plus 4 root 3 minus 8 over 2. All right, so now we're good. We don't have the denominator going on there anymore. But if we are going to rationalize, or sorry, if we are going to add fractions like this, what we need is a common denominator. So if I need a common denominator, what I'm going to do is I'm going to I'm going to multiply each side by something so I get the common denominator. So what I mean by that is, well, I need to find a number that 7 and 2 both go into, right, for my common denominator. Well, that's 14, right? So let's multiply this side by 2, right? Because that'll do it. 2 times 7 would be 14. But I also have to multiply the top by 2. And then over on this side, I'm going to multiply this by 7 and the top by 7. Okay, so if we do that, we're going to have 2 times both of those. So this will be 28 root 3. And then 2 times negative 21 will be 42. All over 14, right? 2 times 7. Plus, and then we've got 7 times both of those. So we get 28 root 3 minus 56, right? 7 times negative 8. And that's all over 14 as well now. Okay, so now that I have this was a hard question. Yeah, so if you guys got this, that's like good on you. That's why I needed the bonus. Okay, so if we did this, then what we're going to do is we can just add the tops now, right? So it'll be, this whole thing is going to be over 14. But then the top will just be 28 root 3 minus 42 plus 28 root 3 minus 56. All right, so if we collect our like terms on the top, right, 28 root 3, 28 root 3, this ends up being 56 root 3, and then minus 98, all over 14. And that is right, we've kind of done it. The only thing is we can simplify this a little bit. I can say, okay, what goes into 56 and into 98, and I can factor out, right? Because I can't just start canceling 56 with 14 or 98 with 14. I want to figure out what's common to this term and this term first, and then factor it out. Okay? So what goes into 56 and into 98? Well, ends up actually being 14 does, right? 14. Okay, so I factored out 14, so what I would have left there now, after I divided by 14, would be 4 root 3. And then 98 divided by 14 would be 7, so minus 7 all over 14. So my 14s cancel, and I end up with an answer of 4 root 3 minus 7. God, I hope that's one of the answers. 4 root 3 minus 7, 4 root 3 minus 7. Nice. All right, so the answer there was C. Okay, number 8. A radical expression is being simplified. In which step of the process was an error made? All right, so what they did, they need to rationalize, right? So what they just multiplied the top and bottom by root b in order to get rid of that square root there. Okay, so let's see. So they went. Okay, so they went root b over root b. Okay, so that's what happened on the bottom here, right? They wrote a little different. They got the root b there and the root b there now. Didn't really change anything. That is what's happening here, right? And then step B, they really distributed. That's like another way of showing that distribution property, right? Root b times root b, b times 6 root s, right? That's what we did when we distributed, right? And then the bottom here looks kind of weird because that's not what happens, right? If you go root b times root b, we talked about this a few times, right? Root b times root b is just b. So not 2b, just b. Okay. All right, so yeah, so it's going to be d. That's kind of a confusing way, I guess I set that up, isn't it? Hopefully you didn't put b, because that, okay, yeah. So the answer was d. All right, 9. Okay, so solve this one. All right, so my onion analogy, right? I need to get rid of this square root first, so I need to square it. So this is going to, so square both sides, though, right? Whenever you do the one side, you have to do the other. So this, so squaring a square root cancels. I've got 7x is equal to 25, and then getting rid of this 7, divide by 7, divide by 7. Well, that's really it. That's as far as I can go. So 25 over 7. Okay, this one, a little bit different order, right? Because, so if I've got square root of 4x minus 5 is equal to 6, well, the outside of my onion now isn't going to be the square root, right? This negative 5's got to go first. And how do I get rid of that 5 that I'm subtracting? I add, right? So you'd add 5, add 5. So we've got square root of 4x is equal to 11. Okay, now it's just like the last question. So I'm going to square it. I'm going to square it. So we get, okay, so the square and the square root cancel. So we get 4x is equal to 121. Divide by 4. Divide by 4. Does that simplify? No. So that's all we can do. So C. Okay, moving on. All right, so solving this one. All right. Okay, number 11. Sorry, guys. Yeah, for this one, solving the whole thing the proper way is a little bit more difficult than what we've done. Like, we will be doing this in like another in the next unit here, but there is a step on this that you guys won't be able to do. You might have been able to get the right answer just by guessing and checking. You could have thrown ends up being C, right? If you end up throwing these numbers into this, you can just check to see which one actually does end up being true. But that's not technically solving, so again, I'll make that a bonus. Yeah, I'm not going to go through it because there is something that we haven't done here. So again, sorry about that, guys. I just kind of, for this practice test, used our test bank, but I'm finding some problems here. So yeah, well, you guys, your mark keeps going up, I guess. Okay, yeah, so I'm going to skip that one. All right, this one we can definitely do. Okay, so the square root of x plus 3 is equal to the square root of 2x plus 8. Okay, I'm going to square both sides, right? Square both sides. So the square cancels with the square root, square with the square root, and we get x plus 3 is equal to 2x plus 8. All right, this is more our style. Okay. All right, so now x is on the same side, numbers on the other. I'm going to bring this x to the other side. Yeah, so we don't end up with negative x's. So we would have, so it's minus x minus x. Here, I'll actually do it in case your algebra skills are rusty here. So x plus 3. So what I would do is I'd subtract x from both sides, right? Minus x minus x. So we'd have 3 is equal to 2x minus x is just x plus 8. And then I'd subtract 8 from both sides, so minus 8. So we'd end up with negative 5. So 12 is B. Okay, and then 13. What are the restrictions on x if the solution to the equation is all of that? All right, so none of that, like a whole bunch of that didn't really matter, right? It's really this part of it that I even really care about, right? So square root of 4 minus x. All right, so restrictions. I can't take the square root of a negative number. That's the idea here, right? So if I can't take the square root of a negative number, whatever 4 minus x is, x like the number that x is, I can't have that being 0 when I go 4 minus that. So what we can do is to say, okay, well, what would x have to be in order to make it 0 underneath the square root? And you can probably see that, right? 4 minus 4 would make that 0, right? So if x was 4, then that would be 0. So it's something to do with 4 here. You can probably see right away that's going to be the answer, is because of that, right? But just to double check here, right? This one's saying x is less than or equal to 4. Well, try it out, right? So if I put in a number for x that's less than 4, right? So let's put in 3, right? So if I put a 3 in for x, well, then that would be 4 minus 3. That'd be the square root of 1. Yep, that's good, right? That is true, so that's allowed. Let's try the other one though. Let's find a number that's bigger than 4, right? And see what ends up happening. So if we have the square root of 4 minus x, and I put in a 5, right, and something that doesn't follow my restrictions, well, that would be 4 minus 5. I've now got the square root of negative 1. That's not allowed. I can't do that, right? You can't take the square root of a negative. So yeah, this is how it pans out there. All right, moving on. Okay, the entire radical, this guy, converted to a mixed radical in the simplest form this is a law like number 1, right? So it's a 4th root, so we need to find perfect powers of 4. All right, so if I wrote down my powers of 4, right? 2 to the power of 4 is equal to 16. 3 to the power of 4 is equal to 81. And then 4 to the power of 4 is too big. 4 to the power of 4 is 256. So it's not going to be that number. So the only thing that could go into 243 is going to be 81 or 16. So if you're unsure, I'd go 241 and I divide it by those, right? So try going 243 divided by 81. And you get 3, right? So this one does work, right? So I can rewrite this as 4th root 243. I'm going to rewrite that as 81 times 3, right? Because I know what the square or the 4th root of 81 is. It's 3. Okay, and now x squared, or sorry, x to the power of 12. Well, let's see. So maybe that one's already good to go, right? So so 1, 2, 3, 4. I could write this as x to the power of 3 times x to the power of 3 times x to the power of 3 times x to the power of 3, right? That would give me the x to the power of 12, right? So the 4th root of x to the power of 12 is x to the power of 3. So I don't need to change that. So I'm going to leave that as x to the power of 12. All right, so now let's just start taking things out. So 81 gets to come out as a 3. And the x to the power of 12, 4th root of that is x to the power of 3. So x to the power of 3. And I still have left in there this 3. All right, so that's my answer. Okay. The conjugate of this binomial, well, the conjugate is the exact same thing, except that's a negative, right? So you change the sign on the second one. So this would be the square root of negative 3x minus 9. That's what the conjugate is, right? And the product of the two conjugates is, so this is where we're going to multiply them. So we'd say square root of negative 3x plus 9 times the conjugate, right? So we'll go negative 3x minus 9. And what's going to happen is my middle terms cancel out, right? That's the whole point of a conjugate, is that it's nice because the middles cancel. So I'll do the whole thing again to show you why the middles cancel. But we've got square root negative 3 times square root negative 3. Well, that's just negative 3x. I've explained that a lot, so I'm not going to go into that again. All right, so then this one times the last one there is just negative 9 square root negative 3x. Okay, and then same thing but a positive symbol. So plus 9 square root negative 3x. Okay, and then 9 times negative 9 is negative 81. All right, so here was the whole point for the conjugate pair. Negative 9 and then root negative 3x plus 9 root negative 3x those cancel, right? Negative 9 plus 9 is 0, so they're gone. So we end up with just negative 3x minus 81. Okay. All right, so when the denominator in this expression, yeah, is rationalized, the equivalent expression is. All right, so here's why we do that conjugate pair thing, is for a situation like this. So we'd start out with 7 root 11 divided by negative 9 minus root 33. Now I'm going to multiply the bottom and the top by negative 9 and then plus root 33, the conjugate pair, right? But I can't just multiply the bottom by that. I also have to multiply the top. So negative 9 plus root 33. Okay? And now I need to multiply the tops and the bottoms here, right? So I'm going to go 7 root 11 times both of those. Okay, so that ends up being negative 63, and then plus square root of 363, right? 11 times 33 over, now this one's going to clean up a lot better. And at this point, right, it's really like this. I don't even really need, because really I do the whole FOIL thing, right? But I don't even really need the middle two, because I just kind of showed on the one before that they cancel out, right? That's the whole point of the conjugate pair thing. So I'm not going to do that again. This time I'm just going to do the front, right? That one times that one, and the back. Because I know the two middle are going to cancel anyway. All right, so if you don't trust me, do the whole thing, but the middle two terms should cancel out. So negative 9 times negative 9 is going to be positive 81. And then negative root 3 times positive, or sorry, root 33 times positive root 33 is going to be negative, and then just root 33. Or sorry, just 33. Because root 33. Just 33. All right, so this 363, I got to see if there's anything that can come out of that. All right, so we can come over here. This is going to be negative 63 plus, and then I can split up 363 as 121 times 3, right? The square root of 121 is 11. So I can bring that as an 11. Okay, over 48. Okay, so this gets to come out as an 11. So I've got negative 63 plus 11 root 3 all over 48. And that turns out to be as simple as we can do. So that's your final answer there. Okay. All right. So yeah, tougher one, right? I knew this one was going to be the tougher question there. So yeah. Okay. All right, so again, inside of my onion, right? So I'm going to get rid of this minus 3 first. So I'm going to add 3. So far I've got the cube root of negative 2x plus 4 is equal to negative 1. Okay. And how do I get rid of a cube root? Well, I cube it. Right? So I'm going to cube both sides. So the cubed and the cube root cancel. So I get negative 2x plus 4. And then here's the million-dollar question. What is the cube root of negative 1? Is it positive or is it negative? It's going to be negative, right? The odd exponents would still give you a negative number there, right? If this was an even exponent, like 2 or 4 or 6, then this would become positive. But since it's odd, still negative 1. All right, so now we're going to go minus 4, so we get negative 2x is equal to negative 5. Okay, divided by negative 2, divided by negative 2, so x is equal to 5 over 2. All right, we're almost done. Wow. Okay, matching. So I think the easier way here is I'm just going to start I'm going to start simplifying these and stuff. Let's see if I can start getting some of these other ones, right? So I'm going to rewrite this as 4 root 3 minus 9 root This ends up being, I can split it up as 64 times 3. So 64 gets to come out as an 8. Okay, so I got 4 root 3 minus 9 times the 8 I'm bringing out here is negative 72 root 3. So then in the end, 4 minus 72 is negative 68 root 3. All right, so 1 is C. Okay, next one. It doesn't really matter which way we go. I kind of have the benefit of knowing which ones are which. So we could start taking stuff out of here, or we can put it back in to see if we can make it look the same. Ends up being, though, you know, if I was doing this, this one looks a lot like this one, right? With maybe some stuff put in there, and it is in fact the same. So let's see. What we can do. Let's see what we can take out of here. Okay, so I'm going to rewrite this as 4x times the cube root, and instead of 24, I'm going to split that up as an 8 times 3, because I know what the cube root of 8 is, right? It's 2. So times x to the 11, but I'm going to split this 11 up as x to the 9 times x to the 2, because I know what the cube root of x to the 9 is. It's x to the 3. Right? We've gone through that a few times. Okay, so now I can start taking out what I can, so that 8 gets to come out as a 2. The x to the 9 gets to come out as an x to the 3. So if I write this out, I got 4x times, you know, this 8 that I brought out as a 2, times, and then x to the 9 that I brought out as x to the 3. And then I've still got the cube root of 3x squared left inside. 3x squared, and then just multiplying my numbers there, I've got 8. 4 times 2 is 8, and then x to the 1 times x to the 3 is x to the 4. And then cube root x, 3x squared. Okay, so yeah, it does in fact give you e. All right, number 3. Number 3 ends up being 4 root 3 over root 8 minus 9. That's a conjugate pair one. I'm going to multiply the top and bottom by root 8 plus 9. So root 8 plus 9. Okay. So the top here, if I distribute, ends up becoming 4 root 24 plus, and 4 times 9, 36 root 3. All over, and then remember this conjugate pair thing, I only actually have to do the front one and the back one because the middles are going to cancel, right? That's the whole point. Okay, so then we end up with root 8 times root 8 is just 8, and then minus 81, 9 times 9. Okay, and then I'm going to simplify this a bit. I'm going to split this root 24 up as 4 times 6. Plus 36 root 3. Okay, negative 73, just 8 minus 81. Okay, 4 gets to come out as a 2, so this ends up being 8 root 6 plus 36 root 3 all over negative 73. I'm hoping that's one of them. It's supposed to be B. Yep. Alright, so here we go, that's B. Okay, this one shouldn't be too bad, right? We're just going to multiply straight across. I know this right away, though. That's got a square root of an actual perfect square, right? I'm just going to call that 3. So I'm going to right at the back call this 4 root 3 times 8 times 3. Right? 8 times 3, because this is just 3, square root of 9, right? Okay, so this part is just 24. Okay, so in the end, if you just multiply all those together, we get 96 root 3. And this one's supposed to be A. Do we have that? 96 root 3? Yep. And then the last one. Okay, number 5. Okay, so what I'm going to do I got a feeling it's going to be F, right? Actually, I got the key, so I know it's going to be F. But so what I'm going to do, I'm going to rewrite this a little bit different. So I'm going to write this as 4 root 5 over 5 root 20x. This isn't the only way to do it, but I don't know. This one doesn't have a square root in the bottom, and this one does. So what I'm going to do is I'm going to try to get rid of the square root in the bottom and see if it starts to like resemble this one a bit more, right? A lot of it's just kind of playing around with it to get what you want. Okay, so if I do that, what I'm going to do, I'm going to get rid of the square root in the bottom. I'm going to rationalize it by going square root of 20x and then square root of 20x on the top. Okay, so now this becomes 4, right, just doing the top here, 4 times 5 times 20 into the square root. This will be 100x. Well, that's promising because 100x, right? Over, and then 5, and then 20x, and 20x, square root though, so this just ends up being times 20x. All right, so then on the bottom here, 5 times 20, or I'll write it again, so 4 root 100x over 5 times 20 is 100x. Okay, and then if I just simplify this fraction, that ends up being 1 over 25 or square root of 100x over 25x. So same as the top there, right? So this ends up being F. Okay, so yeah, sorry about any mistakes, or not mistakes, but questions that were a little bit too difficult on that one. Like I said, I'll change that on your guys' marks, so they'll be reflected there. Email me if you're unsure, and hopefully if you guys are looking at this in previous years, I've already fixed those problems, so, or in, not previous, in future years, I mean. Okay, so that's it. Sorry for the long video, and see you guys in class.